You're welcome to this channel. In our previous video, we looked at limit of a function, but then we focused on the standard formula of limit. Now, in this video, we are going to solve more examples on limit. Okay, so before we proceed with that, let's look at this particular example on the screen. It's very simple. So this example that we see on the screen, we can solve it this way. We can straightforward plug in the 2 into the function. So let's plug it into it and see if we will arrive at the final answer and the correct one, of course. So plugging in the 2, it's going to be 2 squared minus 4, all divided by 2 minus 2. And 2 squared is 4 minus 4, all divided by 2 minus 2. So we can see that our final answer is 0 over 0. Now 0 over 0 on a calculator is simply undefined, okay? And undefined is a figure that you can never tell which value it is. So automatically you can see that our answer to this question is wrong. Therefore, we need to use different approach, or there is something we need to consider. Okay, so let's use another way. Now, if you look at the numerator of the function, you can see that it is what? Difference of 2 squares. So because it is difference of 2 squares, we are going to expand it. So it's going to be limits as x approaches 2. Okay, so expanding the numerator, it's x minus 2 and x plus 2. Okay, all divided by x minus 2. Alright, so here we can see that the numerator and the denominator, one of the numerator can be cancelled out by the denominator, which is the x minus 2. So this can cancel out this, which should be left with limit as x approaches 2. As x approaches 2, x plus 2. So here, what we are going to do is we are going to plug in the 2 into the function straightforward, because if you look at this final answer for the simplification, there's nothing we can do about it again. We can never further simplify it. Therefore, we're going to plug in the 2 into the function. So plugging in the 2, it's going to be 2 plus 2, which is equal to 4. So this is our final answer. Okay, so what I'm trying to show you is that if a question is given like this, what you need to consider is that look at the question, look at the function in the question, and see if that function can further simplify or it can be simplified. If it can be simplified, then you simplify it. If you simplify it to its simplest form, then you plug in the number that x approaches into the function you've gotten as your final answer. Okay, then if you do that, you're gonna get your answer to be correct. So let's proceed with the examples that we are gonna solve. Okay, so these are the examples that we are gonna solve. So there are 6 examples. Okay, 1, 2, 3, 4, 5, 6. Alright, now you can pause the video and try your hands on them and see if you can get the correct answer. Okay, alright, so let's get started. Alright, so let's start with the first one. So the first one, limit of x plus 2 as x approaches 3. So what we are going to do is that we are going to straightforward plug in the 3 into the function. So it's going to be 3 plus 2, which is equal to 5. And that is our final answer. Let's continue with our question 2. So limit of x squared plus 1, okay, as x approaches negative 2. So here, as just like we solved the first one, we are going to plug in the negative 2 into the function. So it's going to be negative 2 all squared plus 1. And answer here, negative 2 all squared is 4 plus 1, which is equal to 5. And that is our final answer. Alright, now let's consider our third question. Okay, so our third question too is limit of x squared minus 4x plus 2 as x approaches 2. The same way, we are going to plug in the 2 into the function. So it's going to be 2 squared minus 4 by 2 plus 2. And 2 squared is 4. Minus 4 by 2 is 8. plus 2, which is equal to, so 4 minus 8 is what? Negative 4 plus 2, which is negative 2. Okay, let's solve our fourth question. So the fourth question is limit as x approaches infinity. Sorry, so that is the fifth one. Let's solve the fourth one. So limit as x approaches 2 of x squared minus 7x plus 1 0, which is 10, all divided by x squared minus 4. So looking at this question, you see, if you look at the function in the question, you can see that the function can be simplified. Okay, if it's straightforward, if you go ahead and plug in the 2, automatically, if you try your hands on it and you solve it, you're gonna get 0 over 0, which is undefined, and it doesn't work that way. Okay, so let's simplify it and go ahead and solve it. Okay, so simplifying this, we need to expand it. So we use factorization method, and expanding this, it's gonna be limit as x approaches 2. So this is going to be x minus 2 and x minus 5, all divided by, so simplifying the denominator 2. So that one is difference of 2 squares. So expanding it is going to be x minus 2 and x plus 2. Okay, alright. So here we can see that this x minus 2 can cancel out this x minus 2. So it will be left with limit as x approaches 2 of x minus 5, okay, divided by x plus 2. Alright, so here there's no way we can further simplify it. So up to this stage, we can go ahead and plug in our 2. So plugging in the 2, going to be 2 minus 5, all divided by 2 plus 2. And 2 minus 5 is 3, negative 3, divided by 4. So this is our final answer for the question 4. Okay, alright, let's solve our fifth one. So for our fifth question, that is limit as x approaches infinity, okay, of 2x cubed minus 7x plus 3, all divided by x squared minus 4. Sorry. So that is x cubed plus 2. Alright, okay, so that's the question. So solving this question, this includes infinity. So because it includes infinity, we can't plug in the infinity into the function straight ahead. No. So what we are going to do is we are going to divide each term of both numerator and denominator by the highest power of x, and the highest power of x in the function is x cubed. So if we take each term, then we divide it by the highest power of x, which is x cubed. So here's how it's gonna be. So that's 2x cubed divided by x cubed, okay, minus 7x divided by x cubed plus 3 divided by x cubed, all divided by the denominator. Okay, the first term is x cubed divided by x cubed plus 2 divided by x cubed. Okay, alright, so let's continue. So we can see that this can cancel out this, then this can cancel one of this, so it will be left with x power 2. Then here too, this can cancel out this, so it will be left with limit as x approaches infinity, 2 minus 7, okay, 7 over x squared, right, plus 3 over x cubed, all divided by 1 plus 2 over x cubed. Okay, so here this is gonna be the simplest form. That's why we simplify. This is gonna be the last the last function we are going to get after simplifying this. Okay, so now what we are going to do is, since this is our last one, we're going to plug in the infinity into it straight ahead. So plugging in the infinity, I'm going to be 2 minus 7 divided by infinity squared plus 3 over infinity cube, all divided by 1 minus 2 over infinity cube. Okay, so 2 minus, and we already know that 1 over infinity is equal to 0. It doesn't matter the power of the infinity, and also the number here, it doesn't matter. Okay, so since we know, we have this in mind, let's apply that formula here. So we have our 2 minus 7 over the infinity squared is 0. Okay, then 3 over infinity cube is also 0. So that's 2 minus 0, all divided by 1 minus, here to 2 over infinity cube is also 0. So our final answer is going to be 2. Alright, so this is the final answer for the question 5. Now let's solve the question 6. Okay, so let's solve our last question, which is question 6, of which after that we are going to draw the curtains down for this video. Alright, so solving this question, what we are going to do is we are going to simplify the function here to its simplest form. Then after that we plug in the 9. Okay, so simplifying this to its simplest form, you can see that the denominator is an irrational function, therefore we rationalize it. So rationalizing this means that we find the conjugate of it, and the conjugate of this is going to be 3 plus root of x. So after finding the conjugate of it, we multiply the conjugate by both the numerator and the denominator. Okay, so let's continue. Alright, so we have limit as x approaches 9 minus x multiplied by the conjugate, which is 3 plus root of x. All divided by 3 minus root x, 3 plus root x. Okay. Alright, let's continue. So for the numerator, let's maintain that for now and focus on the denominator. So focusing on the denominator, we need to go ahead and simplify it. So we can simply see that it's really obvious that the denominator is difference of 2 squares, because the functions here are the same, just that the operation between the two terms are different. This is subtraction and addition. So since they are different, it means that they are difference of 2 squares. So because they are difference of 2 squares, we take the first term, then we square it. So the first term happens to be 3, and we square that, minus the second term, which is root of x. We square that one as well. Alright, so this is our next move. All divided by, so 3 squared is 9, minus square of root x. What is going to be the answer? So if you have root x squared, it is obvious that the 2 here is going to cancel the root, which is going to be left with x. Alright, so we can also see that the numerator and the denominator, the 9 minus x can cancel this 9 minus x here. So it's going to be left with only this. Alright, so it's going to be left with 3 plus root of x. So this is our simplest form for this function. Okay, this is what we can get after simplifying this into its simplest form. So this is the final solution for that. So since we've gotten the final solution for the simplification, what we are going to do next is that we are going to plug in the 9 straightforward into the function. So plugging it into it, whenever we see x, we put 9. So it's going to be 3 plus root of 9. And root of 9 is what? It's 3. So 3 plus 3. Okay. Alright, so our final answer is 6. So our final answer for the question 6 is 6. Alright, so this is where we draw our curtains down for this video. I hope you subscribe for more videos that are yet to come, more tutorials that are yet to come. Thank you.